Okay, so this is the third and final video I'm going to do on graphing piecewise functions, and as you can see here, I got a bit of a bigger one here, okay? So make sure that you went through the other two and have practiced this on your own before we go ahead and tackle this problem, because this one's going to be a little bit longer. So in this particular piecewise function, notice we have four subfunctions. We have four total subfunctions, which means we're going to have four pieces to this graph, okay? And three of these subfunctions are lines, and we actually have a quadratic right here, an x squared, a quadratic that's going to create part of a parabola. So let's jump right in. So the first line, okay, the first line, I am graphing y equals x plus 3 when x is less than or equal to -2, okay? Now remember, what this is saying is that this graph is going to stop when x is -2, so I definitely want to know what that point is. So I'm going to plug in -2 for x, so I get y is equal to x, which is -2 plus 3, and that's going to get me 1. So I'm going to have the point -2, 1. Okay, so I'm going to go ahead and plot that, and since it is or equal to, this will be closed, okay? Remember the starting and stopping points. We got to think about whether it's going to be an open or closed circle, and that's dependent on whether or not it is or equal to, okay? Since this was or equal to, it's going to be closed, okay? And now our slope is 1, so I would be going up 1, right 1, up 1, right 1, but this is when x is less than or equal to -2. So I want to be going to the left. So I'd be going down 1, left 1, down 1, left 1, down 1, left 1, and now I'll just continue this because it's when x is less than -2, which is when x is -3, -4, -5, -6, and so on and so on. So there is our first subfunction graphed, okay? That's our first piece, all right? Now our second piece, we have y equals x squared plus 1 when x is in between, when x is in between -2 and 1, and notice neither of these are or equal to, okay? So both of these will be open circles. Now, we haven't graphed quadratics just yet by hand, so my recommendation, and even if we did graph these by hand, my recommendation would be to make a table for this, okay? My recommendation would just be to make a table, okay? And we're going from -2, starting at -2, and we're stopping at 1, okay? And I'm going to want to find pretty much every nice point in between. So since this doesn't have like a constant rate of change, it doesn't have that slope, I'm just going to go ahead and make a table. So when I plug in -2, I'm going to have -2 squared plus 1. Well, -2 squared is 4. That's going to get me 5, okay? If I were to plug in -1, so you can just go ahead and do this with the rest of the points. When I plug in -1, -1 squared is 1. 1 plus 1 is 2. If I plug in 0, 0 squared is 0. 0 plus 1 is 1. And 1 squared is 1. And 1 plus 1 is 2. So I'm going to go ahead and plot these points, okay? But remember, this is starting when x is -2 and stopping when x is 1. And neither of these are or equal to, so both of these will be in an open circle. That point technically doesn't exist there. So we're going to have -2, 5 with an open circle, and we're going to have 1, 2 with an open circle. But everything in between works, okay? Everything in between works, so everything else is just going to be normal. And as we can see here, this creates part of a parabola, because remember, quadratics have the shape of parabolas when graphed, okay? So that would be our second part. Now, from there, we have y is equal to -9 when x is in between 1 and 6. When x is in between 1 and 6, and notice both of these are included. So I'm going down to -9. Remember, this is just a horizontal line at -9, so I'm going to go down to -9. Since it's or equal to, I'm going to have that close, and it ends when x is 6, and that's also or equal to, so that's also closed. So We can plot all the points in between, but since there's a horizontal line, we can just quickly kind of connect those. Okay. And finally, we have y is equal to negative x plus 7 when x is strictly greater than 6, okay? So remember, that means that it's starting when x is 6, so I'm going to want to find out what y is at that point. So I'm going to plug in 6. So we're going to have negative x plus 7. So it's going to be negative times 6, so it's going to be negative 6 plus 7, which is going to get me 1. So that means that we have the point 6, 1. Okay, 6, 1. And since it's not or equal to, that's going to be an open circle, okay? And from here, the slope is negative 1. So I'm going down 1, right 1, down 1, right 1. And notice this when x is greater than 6, so that's when like x is 7, 8, 9, 10, and so on and so on. So that's why I'm going to the right. Oop, I totally messed that up. My apologies, guys. Should just be down 1, right 1. For some reason, I skipped. Down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. So this will be the last part of our graph, and that's our piecewise, okay? We had 4 different sub-functions, and I have all 4 graphed, okay? So these problems aren't the most difficult. You just got to be careful where the graph starts and stops for each individual rule, okay? If you take this one step at a time, it's not going to be too much to handle, okay? So make sure that we're practicing piecewise functions. That was the third of 3 videos on graphing piecewise functions. In the next one, we'll kind of talk about how we can apply these to real life situations and kind of take a look at a bit of a word problem. So make sure that you check that out.